Okay, in the last video, which I recorded all of 5 minutes ago, we were looking at this CUDA software worksheet. Once again, I have put a link to the worksheet in the description. We did the first 10 examples. There are 8 more, so let's get started. Okay, here we are at number 11. We are looking for the measure of arc CFD. So we need to get from C to D, but we need to go through F. So that's this very, 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 very large arc right there. Arc CFD. And we want to know the measure of that arc. Well, we've got bits and pieces of it, right? We know that this bit is 81 degrees. We know that this bit is 135 degrees. So we really just need to know this arc and this arc, which means we need to know this angle and this angle. Now, I want you to take a second and look at this, and this should look familiar. Like, strip away all of the excess nonsense and just look at these two. That's awful. Just look at these two lines. What can you tell me about those two angles that I've marked? Well, those are vertical angles, right? You've got two crisscrossing lines, and those vertical angles, whatever they are, they're going to be congruent to each other. I don't know exactly what it is, but I know that they're the same by vertical angles. Again, the stuff that we learned before, it keeps coming back. Okay? So once we find one, then we'll find the other. Well, speaking of straight lines, if you look at this straight line here from F to C, that straight line right there, we learned in class that a flat line, half a circle, is 180 degrees. Well, if this part is 135 degrees, then we can take 180 degrees and we can subtract 135 degrees, and that'll give us, let's see, 80 minus 35, 80 minus 30 is 50, so 45 degrees. So we now know that both arc BC and arc FE are 45 degrees. So now to find the total arc, we just got to add them all up, which I'm not going to do in my head. Hey, Google, what is 81 plus 45 plus 135 plus 45?
The answer is 306.
306. There we go. So the measure of arc CFD is 306 degrees. That took a little longer than expected. Let's move on. Number 12. We want the measure of angle SPQ. Now, I take this marking to mean that these two are congruent. Okay? So let's see what we've got here. We've got 86 degrees in here. So now how do we figure out what those two angles are? Pause the video, see what you can do. Well, I have almost this whole circle, right? I'm going to call these two X degrees because I'm super creative. And we've got the whole thing, right? We know that this bit is 60 degrees. We know that this bit is 154 degrees. And we know that all circles add up to 360. So we're going to take that 360 degrees and we're going to subtract 154. And we're going to subtract 60. And we're going to subtract 86. And whatever that is, we'll cut it in half and we'll be done. There's an algebraic way to do this too, but not everybody thinks in algebra. Hey Google, what's 360 minus 154 minus 60 minus 86?
The answer is 60.
60. But be careful, 60 is this whole arc here, right? Since those two are each equal, the actual answer, the measure of angle SPQ, is 30 degrees. You got to divide it by 2 because there are two angles that are congruent to each other. That's number 12. Number 13, we're looking for the measure of arc EFC. Now you'll notice that I am marking with a highlighter the arc or measure of the angle of whatever it is I'm looking for. It helps me. Maybe it'll help you. EFC. So that's EFC. I don't know if you can even see that gray, but I'll make it a little bit darker. Okay. So we've got part of it. We know that this is 126 degrees. Once again, we have vertical angles here. And oh, look, if you look at these two lines here, if you look at those two lines there, we know that these two angles across from the 126 degree angle, they're equal to each other. I'll mark them with 2. And they make vertical angles with that 126 degrees. So this whole arc CE would be 126 degrees, which means each piece would be half of that, which is 63 degrees. And now that we know that, we can again add up to 360 to figure out what these two are. And this time I will set it up algebraically for those students who prefer that. So I'm going to call each of these x degrees. And I'm going to say 2x, because there's 2 of them, plus 126 plus 126 equals 360. 126 plus 126 is 252. We will subtract 252 from both sides. Let's see, 360 minus 250 would be 110, minus another 2 is 108. Divide both sides by 2. X equals 54 degrees. So we now know that these two x's are 54 degrees. So what was I originally looking for? I now know every single one of these angles. What am I actually looking for? I wanted measure of angle the measure of arc EFC. So that looks like it's 54 plus 126 plus 54. That is not good, nice, neat work. I'm not going to put that over there. I'm going to do the good thing and put my work underneath. So 126 plus 54 plus 54 equals. That's 126 plus 108, so that's 234 degrees. It's not the only way we could have done that. We could have also taken the 126 away from 360. Hey Google, what's 360 minus 126?
The answer is 234.
So that would have gotten us the same answer either way. Lots of different paths to get to the same answer. That's number 13. All right, number 14. Hey, look, more vertical angles. We're looking for, I don't care what we're looking for yet. Let's find all these angles first, and then we'll figure it out, okay? If this arc, JK, is 55 degrees, then this angle, the central angle, is also 55 degrees. But because it's vertical angles, this angle MIL is also 55 degrees, which means this arc ML is also 55 degrees. So far, so good. Now, these are straight lines, which means we can say that this angle here is 180 minus 55, right? A straight line is 180, we've got 55, so it's 180 minus 55, which is, I believe, 125. And again, just like everything else, if that one angle is 125, well then so is this other angle by vertical angles. And so is this arc, 125, and so is this arc JM, 125 degrees. I like this particular diagram because I really want you to see that central angle and arc measure are really the same thing. They're not the same thing, but they're always equal. Okay, so what are we actually looking for? We're looking for, all right, so we're looking for the measure of angle MIJ. That's this one right here. It's 125 degrees. No problem. Let's do a few more. Number 15. Ooh, equations. So this is a different Khan Academy, one that says arc measure with equations. Solve for x, assume that lines which appear to be diameters are actually diameters. So again, there's going to be a lot of vertical angles, right? Now, I'm going to do this without solving for all of the unnecessary stuff, and I'm going to start going pretty quick because we've been doing these now. But again, if you have any specific questions, you can always take a screenshot of the spot that you're confused about, email it to me, and I will happily explain it to you. Okay. So we're solving for x. Here we've got a straight line, which means that this angle here must be 180 minus 140. 180 minus 140. I'm going fast. That doesn't mean I'm not going to show my work. That's 40 degrees. Well, now I know, because that angle is also this angle, 40 degrees. Again, vertical angles, right? I now know, I don't know what x is, but I know that 6x minus 8 is going to equal 40. Again, the measure of the arc equals the measure of the central angle. The central angle is 40 degrees. The arc has a measure of 6x minus 8. So those two values must be equal, and we can use that to solve for x. We get x equals 8. Okay, so we have these two angles that appear to be congruent, and they're on a straight line, which tells me that we know exactly what they are. They're both right angles. This is a 90-degree angle. It has to be. If it's equal to the other one and they add up to make 180, it has to be 90. So now we know that x plus 93 equals 90. Again, because the measure of the arc and the measure of the angle are always equal. We get x equals negative 3. Two more. Find the measure of the arc or central angle indicated. Assume that they're diameters, right? So now we're looking for the measure of arc WV, which is this one right here. Fantastic. So let's see. We know that this angle here, that angle there, we don't know the number, but we do have an expression for it. It's 12x minus 2 degrees, right? This angle here, we don't know. This angle here is 5x plus 10. And this angle here is the same as the other blue one, but we still don't know it. Well, it looks to me, and again, this is one of those times when you have to look really hard at the straight lines that are being made. Remember, vertical angles are almost always going to be a thing here. Okay? And if you look, we've got vertical angles right here. We already knew that they were vertical for the smaller angles, but they are vertical for the larger angles as well. So we can say that 12x minus 2, that's this arc here, is equal to the combination, the sum of these two arcs right here. So 5x plus 5x is 10x, and 10 plus 10 is 20. We can solve this pretty quick, I hope. I get 2x equals 22. Again, I'm skipping steps here. Please don't panic. Do the algebra yourself. It's good practice. I get x equals 11. But x isn't what I'm looking for. I'm looking for the measure of arc WV. So what I'm going to do is I know that I'm going to make this y degrees. I know that 2y plus whatever all that added up to is going to equal 360. And now I'm going to plug my x equals 11 into all of that. The 12x minus 2, the 5x plus 10, the other 5x plus 10. I'm going to plug x equals 11 into all of it because I want to figure out what that number is, right? I need all of that added up. So, hey Google, what is 12 times 11 minus 2?
The answer is 130.
So this arc here is 130 degrees, which means this other arc is also 130 degrees. Remember those vertical angles. So it's 2y plus 260 equals 360. Again, don't get bogged down by the notation. All I did was add up all of the degrees in the entire circle, except for the two that I don't know. And I know that the two unknowns are equal, so I get 2y plus all of that other stuff added up together, which happens to be 260, equals 360 because all circles are 360. You get y equals 50. This video is already running long. Do the algebra. I believe in you. I really do. All right, last one. We want the measure of angle VST, which is this angle right here. It happens to be congruent to this other angle, VSU, which means that this arc TV is also negative 27x minus 3. So the setup for this one is blessedly easy. Just take all three of them, add up to make 360, And then we can solve for x and then use x to find the angle. So we get negative 27x minus 3 minus 27, whoops, x minus 3 minus 37x plus 2 all equals 360. Again, I just took all three of those expressions and I lined them up. I'm technically adding them all together, but it looks like subtraction because they're negative, right? Okay. Hey Google, what is 27 plus 27 plus 37?
The answer is 91.
So we have negative 91x, don't forget that negative. Negative 3 minus 3 is negative 6, plus 2 is negative 4. Just collecting like terms. Add 4 to both sides. I think it's going to be 4. Hey Google, negative 4. What is 360?
I don't understand.
Hey Google, what is 364 divided by 91? I think it's going to be 4.
The answer is 4.
Yeah, that's what I thought. So we get x equals negative 4, which is nice, but not what we were looking for. We're going to take that x equals 4, and we're going to plug it in to the expression that we have for angle VST. Okay? It's okay to get a negative for x so long as you get a positive for your final angle. For your final angle measure, that is. So the measure of angle VST is negative 27x, but we now know that x is negative 4, minus 3. Hey Google, negative 27 times negative 4 minus 3.
The answer is 105.
105 degrees.